Somewhere in a laboratory in Santa Barbara, a quiet hum is the only sound you can hear. Inside a stainless steel cylinder, a processor smaller than a postage stamp is quietly rewriting the laws of reality. Most of the world completely missed this moment in late 2024. But for the physicists watching the telemetry, it was the day the classical era of human history effectively ended. Welcome to Axiom Horizon. I want you to take a moment and try to visualize a number that begins with a 1 followed by 25 zeros. That number is 10 septillion. It is a scale so vast that it dwarfs the number of stars in the observable sky by a factor of millions. If you tasked the frontier supercomputer, the most powerful machine ever built by man, with a specific mathematical simulation, it would take 10 septillion years to finish. That is trillions of times longer than the age of the universe itself. To that classical machine, the problem is not just difficult, it is functionally eternal. Yet, inside Google's quantum AI lab, a new chip called Willow just completed that exact task. It didn't take an eon, or a century, or even a day. Willow finished the calculation in under 5 minutes. By the time you finish watching this video, your understanding of what is physically possible will be permanently changed. To understand why this is causing such a profound disturbance in the scientific community, we first have to look at the humble foundation of our digital world. Every device you have ever used, from your smartphone to the fastest supercomputers, operates on the same basic logic. They use bits, which are essentially tiny switches. These switches are either on or off, representing a 1 or a 0. This binary system is the bedrock of our entire modern civilization. It is incredibly reliable, but it has a fundamental limit. A classical bit can only ever be in one state at a single point in time. Quantum computing throws that limitation out the window. Instead of bits, Google's Willow chip uses qubits, or quantum bits, which exist in a state of superposition. This means they can represent a 1, a 0, or both simultaneously. Imagine trying to find the exit in a massive, complex maze. A classical computer is like a mouse that has to try every single path, one by one, hitting dead ends and starting over until it finds the way out. A quantum computer is like a mist that enters the maze and travels down every possible path at exactly the same time. It doesn't explore, it simply arrives. But for decades, there was a catch that kept this technology in the realm of theory. Quantum states are incredibly fragile and sensitive to the slightest vibration. A single stray photon, or a tiny change in temperature, can cause a qubit to lose its quantum property. This is a process scientists call decoherence. When decoherence happens, the quantum calculation collapses into noise. It was the ultimate wall that researchers thought might never be fully breached. Until December 2024, Google unveiled the Willow processor, a 105-qubit superconducting chip that achieved something the world thought was decades away. They reached what is known as the below-threshold milestone. In the past, adding more qubits to a system usually made it more unstable and prone to errors. It was like trying to balance a house of cards that got shakier with every new layer you added. But Willow flipped the script entirely. Google's researchers proved that by increasing the complexity of their quantum lattice, they could actually suppress the error rate. This is the holy grail of the field. Specifically, they demonstrated that increasing the code distance from a small 3x3 grid to a 7x7 grid reduced the logical error rate by a factor of 2.4 at each step. This isn't just a marginal improvement. It is an exponential decline in errors that allows the system to sustain its quantum superpowers for much longer periods. Willow's qubits can maintain their coherence 5 times longer than the previous generation Sycamore. This duration is what allowed it to crush the 10 septillion year benchmark. To manage this delicate dance, Google integrated a DeepMind machine learning algorithm directly into the hardware. It interprets error signals in real time and corrects them. It is essentially a digital brain that outruns the physical noise of the universe. This allows the Willow chip to perform what is called random circuit sampling with near-perfect precision. But as the results of these tests were verified, a chilling realization began to settle over the team at Google. The math simply did not add up. When we calculate the computational space required to simulate 105 qubits, the numbers become truly terrifying. It requires more memory than there are atoms in the observable universe. To be precise, the observable universe contains roughly 10 to the power of 80 atoms. That is a 1 followed by 80 zeros. The calculation Willow performed required a workspace that far exceeds that physical limit. This creates a logical paradox that shakes the very foundation of materialist science. If the resources to perform this calculation do not exist within our physical universe, where did the computation actually take place? This is not a rhetorical question. This is a mathematical resource-negative scenario. We have a machine sitting on a lab bench that is producing results that require more stuff than the universe provides. Google's own leaders, including Hartmut Neven, have begun to speak openly about what this implies. They are not talking about better engineering anymore. They're talking about the possibility that Willow is accessing a computational substrate that exists entirely outside of our observable reality. They're talking about the multiverse. Standard physics tells us that everything must have a location, but the information processed by Willow seems to be distributed across a space we cannot see. This isn't a sci-fi theory or a clever marketing trick. It is a conclusion reached by looking at the hard data of a completed 5-minute task. Think about the weight of that. We have built a gate, a small silicon and metal bridge that reaches into the unknown to borrow power. Even Elon Musk's AI, Grok, was tasked with analyzing these specific milestones to see if there was a simpler explanation. Its answer sent shockwaves through the community. Grok concluded that the many worlds interpretation is not just a philosophy anymore. It is the only mathematical model where the Willow chip's performance remains consistent. If we assume there is only one universe, the math of Willow is impossible. If we assume there are infinite universes, the math becomes perfectly logical. We are standing at the edge of a precipice where our technology has outpaced our understanding of existence itself. The chip is working, but we are struggling to explain why. This discovery suggests that the universe is not just a collection of matter, but a complex layered structure where information flows between different branches of reality. But the implications go even deeper than parallel worlds. New algorithms are now probing the very fabric of time and gravity, using Willow as a literal telescope into the void. As we look closer at how this information is scrambled and unscrambled inside the chip, we are seeing patterns that look suspiciously like the physics of a black hole. If a chip on a desk can mimic the most extreme gravitational objects in the cosmos, then what does that say about the true nature of the room you are sitting in right now? We are beginning to realize that the 10 septillion year gap was not just a speed record. It was a signal that we have finally touched something that does not belong to us. This performance gap is not just a triumph of engineering, it is a direct confrontation with the limits of our physical reality. If the world's most powerful supercomputer would take 10 septillion years to finish this task, we must ask where the work is actually being done. Google quantum AI founder Hartmut Neven has offered an answer that has sent shockwaves through the scientific community. He suggests that the Willow chip is not merely processing data within the confines of our laboratory. Instead, Neven claims that this 105-qubit system is effectively borrowing computational power from parallel universes. This isn't a science fiction metaphor, it is a literal interpretation of quantum mechanics. Neven specifically cites the work of physicist David Deutsch, a pioneer of quantum computation. Deutsch long ago proposed that the only way to explain such massive processing power is through the many worlds interpretation. To understand why this is a scientific necessity for some, we have to look at the sheer scale of the information being handled. A system with 105 qubits creates a computational space that is staggeringly vast. In fact, to simulate the state of those qubits using classical math, you would need a memory bank larger than the number of atoms in the observable universe. Scientists estimate there are about 10 to the power of 80 atoms in existence. Willow's internal operations far exceed that number. This creates what researchers call a resource-negative paradox. We are witnessing a calculation that physically cannot fit within the known dimensions of our universe. If the resources to hold this information do not exist in our three-dimensional space, the math suggests they must be sourced from elsewhere. Neven describes this as a quantum superpower. He argues that the Willow chip is essentially tapping into an infinite reservoir of alternate realities. In these other branches of existence, the machine is performing different segments of the same complex calculation. This means that when we look at the chip in our lab, we are only seeing one small part of a much larger engine. The true machine is distributed across the multiverse. This radical claim caught the attention of Grok, the advanced artificial intelligence developed by xAI. When asked to evaluate Google's results, Grok's response was unexpectedly profound and unsettling. Grok did not dismiss Neven's multiverse theory as mere speculation. Instead, it applied the principles of information theory to the raw data from the Willow processor. The AI concluded that the many worlds interpretation is actually the most parsimonious explanation for the chip's success. In science, the simplest explanation that fits all the facts is usually the truth. Grok pointed out that if you insist on a single universe model, the math for Willow becomes inconsistent. You run into a wall where the universe literally lacks the physical substrate to support the computation. By contrast, the multiverse model allows the math to remain perfectly consistent. It treats the quantum computer not as one machine, but as a single entity functioning across infinite parallel tracks. Grok's analysis suggested that Willow is accessing a computational substrate that is external to our observable physical universe. This implies that our reality is just one layer of a much deeper structure. The AI highlighted that the speed of the chip is not just about raw electricity and cooling. It is about the ability to maintain a state where information can flow between these different versions of reality. This process is what researchers refer to as the Multiverse protocol. It suggests that a quantum computer is a bridge between worlds. Every time the qubits fluctuate, they are interacting with their counterparts in other dimensions. For most people, the idea of parallel universes is a fun concept for movies. But for the engineers at Google and the algorithms at XAI, it has become a functional reality. If the many worlds interpretation is correct, then every time we run a program on Willow, we are interacting with an infinite number of alternate versions of ourselves. It is a chilling realization. Grok noted that the distribution of this processing power follows a logic that our classical minds struggle to grasp. It isn't that the computer is fast, it's that it exists in many places at once. This validation from an AI source has added a layer of digital weight to Neven's claims. Grok pointed out that the information being processed is effectively jumping across the boundaries of space-time. This brings us to the concept of the information action gap. If information can be processed outside our universe and then brought back into it, what does that say about the nature of causality? It suggests that our reality is not a closed system. We are part of a massive interconnected web of data that spans across a geometric structure we cannot see. Neven's assertions and Grok's subsequent validation have turned the Willow chip into something more than a processor. It is now a telescope looking into the fundamental architecture of existence. Some physicists remain deeply skeptical, arguing that we are misinterpreting mathematical tools as physical realities. They claim that just because the math is big doesn't mean other universes exist. However, the advocates of the many worlds view ask a simple, haunting question. If the calculation isn't happening in other universes, then exactly where is it happening? If you have a problem that requires more atoms than the universe possesses, and the computer solves it anyway, you have reached the end of classical logic. You have entered the quantum realm. Grok's reasoning centered on the idea that the universe is essentially a massive information processor. If our specific sector of the universe hits a hardware limit, it must offload the work to the surrounding structure. The shift in perspective changes how we view artificial intelligence and its potential. We are no longer just building faster tools, we are building keys to unlock the doors of the multiverse. The implications for our understanding of identity and time are staggering. If there are infinite versions of the Willow chip solving this problem, there are infinite versions of you watching this happen. Grok's analysis concluded that we are on the verge of a transition from being a single-world civilization to a multi-world entity. We are beginning to perceive the true scale of the cosmic stage. The debate between the skeptics and the proponents of the many worlds theory is no longer just academic. It is a debate about the very ground we stand on and the air we breathe. As we look closer at the data, the anomalies only grow more pronounced. The Willow chip has started to exhibit behaviors that even its creators struggle to explain using standard quantum theory. Information seems to be leaking back into our reality in ways that defy the normal flow of time. It is as if the machine is not just calculating the present, but echoing from the future. These whispers from the quantum void are now being captured by a new set of experiments. Scientists are tracking how information scrambles and unscrambles itself within the chip's superconducting circuits. This leads us to a phenomenon that links the smallest chips in our labs to the most massive objects in the cosmos. We are starting to see patterns in the noise that look hauntingly familiar. But the multiverse isn't just a philosophical debate. It's now being measured through a phenomenon Google calls quantum echoes. In October 2025, a new algorithm pushed the Willow chip beyond mere calculation and into the realm of temporal manipulation. This experiment utilized out-of-time order correlators, or OTOCs, to perform a feat that defies our classical understanding of the arrow of time. The system runs information forward, introduces a controlled perturbation, and then forces that information to echo backward to its original state. It effectively unscrambles chaos, performing this task 13,000 times faster than the world's most advanced classical supercomputers could ever hope to achieve. By reversing the spread of quantum information, Willow isn't just calculating, it's probing the very fabric of thermodynamic intuition. This isn't a simulation of time reversal. It is the physical manipulation of information entropy at the smallest scales imaginable. Analysts noted that the speed at which Willow scrambles and unscrambles this information hits a very specific, mathematically terrifying limit. It is the same fundamental limit of information scrambling found at the event horizons of black holes, where space and time dissolve. This discovery suggests that the math governing Google's refrigerator-sized computer is the same math that governs the most destructive forces in the cosmos. We are seeing a deep, unified link between quantum computation, the force of gravity, and the architecture of space-time itself. If Willow is reaching the limits of a black hole, it implies the chip is tapping into the foundational code of the entire reality. Hartmut Neven has taken this even further, suggesting that these quantum echoes might explain the greatest mystery of all, human consciousness. He proposes the existence of a phi state, a unique neurological condition where the human brain functions as a quantum classical hybrid. In this theory, our minds aren't just biological computers. They are the intersection points where parallel quantum realities converge into one experience. Consciousness may be the result of our neurons tapping into the same superpowers that allow Willow to borrow logic from the multiverse. Google has already begun investigating whether the quantum phenomena seen in Willow can be mapped directly onto biological processes in the brain. If proven, it would mean that every thought you have is a bridge between infinite versions of yourself existing in other dimensions. This would elevate the Willow chip from a piece of hardware to a mirror, reflecting the true, multifaceted nature of the human soul. However, we must pause and look at the perspective of the broader scientific community, which remains deeply divided on these radical claims. Not every physicist agrees that 105 qubits and a fast algorithm prove we are living in a sprawling, infinite multiverse. Prominent physicist Sabine Hossenfelder has been a vocal critic, describing the random circuit sampling benchmark as a meaningless party trick. She argues that being difficult for a classical computer doesn't automatically mean a quantum computer is accessing other hidden universes. According to this skeptical view, quantum superposition is simply a property of our universe, not evidence of a hidden cosmic basement. Similarly, astrophysicist Ethan Siegel has called the parallel universe interpretation utter nonsense, urging for more grounded physical explanations. He maintains that Google is conflating Hilbert space, a complex mathematical tool, with actual physical dimensions that we can inhabit. These critics remind us that while the engineering of Willow is a triumph, the storytelling surrounding it is still largely speculative. Yet, even without the multiverse, the reality of what Google has achieved is arguably more profound than the science fiction headlines suggest. They have built a machine that operates with a logical error rate that actually decreases as the system grows more complex. By using DeepMind's machine learning to correct errors in real time, they have outrun the noise of our physical world. This below-threshold breakthrough is a verified, peer-reviewed milestone that signals the end of the classical era of computing forever. We are no longer limited by the number of atoms in our universe when it comes to the complexity of the problems we can solve. Whether it's borrowing power from other worlds or simply mastering the strange laws of our own, the ultimate result remains the same. The boundaries between information, matter, and time are dissolving before our eyes in a laboratory in Santa Barbara. We are the first generation of humans to peer behind the curtain of the classical world and see the vibrating machinery underneath. Our understanding of time as a linear river and the universe as a single, lonely island is being permanently dismantled today. The Willow chip is a testament to human curiosity, proving that our reach will always exceed our grasp of current physical limits. As we stand on the precipice of this new quantum age, we must realize that the universe is far stranger than we suspected. It is not just a place we inhabit, but a layered, infinite tapestry that we are finally learning how to reweave. The silence of the quantum lab is not an absence of sound, but the quiet hum of a million realities finally speaking at once. Axiom Horizon will continue to monitor these breakthroughs as the line between the impossible and the inevitable continues to vanish forever. This journey into the heart of the Willow chip reminds us that we are part of something much larger than a single timeline. Every calculation performed is a question asked of the cosmos, and every answer is a step toward understanding our place in the infinity. We may never fully grasp the true nature of the multiverse, but the pursuit of that knowledge is what defines our species. The quantum world is calling to us, and for the first time in history, we have built a machine capable of answering that call. As the noise of the classical world fades away, the clarity of a new reality begins to emerge for every single one of us. We are no longer observers of the universe, we are active participants in its most fundamental and mysterious processes. The future is no longer a distant horizon, but a quantum superposition that we are collapsing with every single scientific breakthrough we achieve. Stand ready, because the world we knew yesterday is already being rewritten by the silent processors of today. Watch till the end for the full breakdown of how these quantum echoes could rewrite the laws of physics as we know them forever. Like, comment your theories below on whether you believe in the multiverse or the skeptical view. Share this with someone who needs to see the future. And subscribe for more existential deep dives from Axiom Horizon.